Hi there. There's a very weird setup about this that's going on for what it's worth. Can't adjust the fucking. See, point is, I want to talk a little bit today more about something really rather interesting to me. I was coming back from hiking with my dog, and I was thinking about like my old battery generator idea that allows for air to go through, kind of like a oxide battery, right? However, fluid's going through it, and it's an AC like kind of compressor, not really, because the battery gets hot, right? So there's a way to allow for light to pass through into this and reflect, and of course it removes by virtually getting states to become a thing here, in the oxidation part, right? But I went, oh, wait, if I'm doing that in an air compressor, like that's a lot, you know what I mean? Like they're not very efficient. So I went, oh, there's a better way to do that for what it's worth, right? All I need is a vacuum. All I need is the peristaltic just means it's doing this, essentially, right? That's all it's going to mean in the end of it. But the fun part is like that little motion is a big motion in terms of how you can add catalytic compounds. And for what it's worth, the fluid that's in there can get very, very close to the surface of this thing, kind of like what we have for our skin, right? Now, the different type of porous structures are a big part of this. So gulp it down, move it in, it'll mix technically, and then we have to go through a filtration. I went, oh, well, that's a compressor right there for you. I just need a vacuum, right, to allow for an increased boost of the energy provided by the air. Okay, and that's my compressor in a way, except I just need to get it to squeeze. So this is vibration that travels out like a branch network that can then get grabbed and changed in its frequency to a smaller point that allows for that air that was oxidizing, kind of like Rust-Oleum in a way. It's an enzyme, Rust-Oleum, the compound that derusts things, and there's a way to use different enzymes in that catalyst with that surface, which are not very expensive, to then make it so it deoxidizes with light. Of course, there's a mechanical part to this, and those wave frequencies have to be very specific, of course, right? But now it's going to work a lot longer. It will have to have the fluid get changed out, but that's doable. And while catalysts are there, the material itself, that's got to be your battery-like material, right, is also able to be benefited from the liquid, the fluid that's there. So I went back to the drawing board of my old battery generator, which is essentially the same thing, but not really. It's a solid state with the battery, it's solid state liquid hybrid, really. But the battery, well, that's cool. It's more of the capacitor and piezoelectrics in a correct structure that allows for, as electricity goes through, and that light coming in, to break apart and then recombine bond-wise what's in our air. So it's a filter that filters a certain way to make more electricity using a fuel cell redox flow like design. Really good stuff. It was not going to be terribly expensive, and it wasn't ever going to be they did forever or anything like that. It just increased the range, and if you could get fast enough, there's a heat pump like activity that starts to happen, and there's a sweet butter zone that would give you a little of that equalization, so to speak. You wouldn't use more than you're using to go at that speed. That's all that means, right? So you can sustain it for a bit, which is great, and it's far more efficient in the air than on the road, because rolling resistance and air resistance are, well, you can get rid of one, it'll help out, right? Fun stuff. But in this instance, I went, oh, well, if I use electric motors as a single wheel nut kind of hydraulic fluid coupler to those wheels, right, that allows for me to have that fluid get moved around anyways. It's basically braking with hydraulic fluid, sort of resistivity, if you will, and how much you have to move fluid-wise and how fast, it's more resistive. Good stuff. But if it goes through something, I can get that to perform work energy with air and light, which can still work at night, which is nice, because what we're really doing is interfering the right way to make sure it has the right light, right? But there are other nice methods too to the madness of this concept that are just like, well, electricity flows, man. And it's like, yeah, I love doing that to people though, because it is basically that. It's like, I'll produce a bunch of these electromagnetic and electrostatic field effects, right? And it's like, but bro, you gotta surf them the right way. And it's like, that's how easy it is to kind of get people annoyed that treat it way too seriously, right? They're silly people in the world of engineering and more. They just don't make sense. They rarely are people I want to deal with. But the point is that, yeah, that's exactly what will work for this design if I can get the batteries to get, pumped through, and I need a radiator anyways and all this other stuff for a car. And I'm like, air resistance isn't a bad thing if you know how to flow it the right way and you know how to use it the right way. Light's already going to be there. I don't have to always use IR. I don't always have to use ultraviolet. But those two are always there. And a heat pump with a static electricity buildup between rolling resistance and air resistance going through gives us a light emission and that electricity necessary to then do this. Now, that's only because we understand that there's a limitation, right? Like, there's no way to get everything perfectly efficient and get more, at least from what we've ever observed. Chasing that demon in thermodynamics, right? I'm on it. But in this instance, that electricity is to potentiate more electricity. It's like there's 5 electrons over here, and if I use 2 over here, I can get the 5, basically. But eventually, we'll have to replace the fluid. And that's okay, because we drink water and we eat food, and it comes out eventually, right? So, hey, normally it's an exhaust pipe. Well, now we can just hook up a standard gas pump and have it flow through. So out and in, so outer diameter and inner tube, then allows for outer flow to then have an inner flow come back in. It sucks that out while you push more new stuff in. How often will it need to be changed? Not very often. That's the benefit of that, right? It's more of, I wanted to make sure it wouldn't be environmentally damaging or expensive to make and manufacture any of this. So that one turns into, that was already done. We already got it in the 30s for the fluid that I would be using in the 1930s. Granted, catalysts and other knowledge of these other physics phenomena and engineering and all that, then that came later. But the fluid is old school. We don't need to use refrigerants or anything that's all that hard to make, which is nice, right? In fact, hydrogen and proton batteries are now becoming a big thing, and you might even be able to use those. But for this one, it's basically bioorganic enzymes. And trash will make them for what it's worth. If you're willing to filter them out, you could actually feasibly harvest it from that and just use that. I'm not going to tell you what it is, though, because for what it's worth, it's kind of one of those things where people find things disgusting, So, but, it's neither here nor there. It's always smell or something that's bothering them, And I don't remember the long name right now off the top of my head. Some chemical compounds are more difficult to pronounce for me too than others. I'm the same as anyone else, So, but I can remember to look it up before I post this, I'll make sure to give it to you in the description down below. Now, this is basically the whole concept in a nutshell, right? So it's like a tiny little two-seater. You get underneath the seats here, towards the center, are batteries, or wheel well, or not wheel well, are wheels, or of course those electric motors with hydraulic fluid. You don't need to do too much to just bolt that sucker in, really. Alright, and then the diffs are a little bit different because it's really just fluid for the battery, so we can get the batteries a little closer to the firewall and down low, and we treat it more like a convertible here, where we want to stiffen the chassis just a bit. Alright, we can get a lot more battery capacity in that center down low, where we're wanting it. Okay, it also allows for us to use the light from the surface, and we really only need small fiber optics to go there, so we just pump those through the center in the right way, and the rest of it's just regular, you already manufacture this stuff anyways, right? You can call it fiber reinforcement if you wanted to, yeah. For what it's worth, it's just fiber optics. Yeah, I didn't really try and do any big major thing on that. It seems expensive for some. If they're not immediately doing that already, and so the manufacturing capacity and more, it could be expensive to have to upgrade and change. So I went, oh wow, a hinge and all this is already hollow. There's holes already in a firewall. All of this is doable. Much more doable. In fact, catalysts are an interesting idea in terms of, you think we need to use like what cars for their exhaust are using. It's like, no, that's platinums and very expensive elements that are not necessary at all. In fact, they're actually worse at doing this than cheaper or ceramic quartz-based, so silicon oxide-based doped catalysts. That means you chemically treat dust, that's just coarse dust, alright? Now, from there, it activates in such a way that it's ready to have a bond potential to create a plate and get much more surface area with a type of design that's more similar to a radiator, right? Now, because we need fluid to flow anyways, we want them to go along channel paths that are closer more in terms of well, what we use daily anyways. So, think more like air-to-air intercoolers and standard car radiators, right? That does mean that the catalysts that I haven't talked about are different. So, I did just talk about the quartz side, but how you dope this matters, right? And the ceramic activation part of it is the thing, because it's already not a ceramic, it's glass, right? But it's a piezoelectric glass. So we need things that are electrically conductive, and we need a battery there anyways. And I went, old alkaline batteries are perfect for this, because they're eating up, well, our dumps, you know what I mean? Like, they're not very good for our environment. So it was a lot easier to use those by refreshing them, by breaking them down effectively. It's just throwing them in a big old soupy pot almost, right? And then going with vibrations. Strangely enough, yeah, that's how easy it is to do that. Besides, you're gonna have to learn how to get better at changing, wave frequencies into different areas anyways. And piezoelectrics really help when you can add the suspension into that as an energy recovery device. Allows for a heat pump like activity too, at different speeds. And it just needs to move a slider to change the dampening and where it goes through and arrives to different pathways and different wave frequencies, because the material and how fast it goes through alters what you're going to get out of it. Which basically means you need to get good and stop saying it can't be done. You're dumb. It turns out you just didn't think hard enough. That one kind of sucks, because engineers are used to that, others are not. That's the thing. Right? Like, we're used to skill issues everywhere, god damn it. And they go, no, it's impossible. And we just treat them as stupid, like normal. Together, yeah, we laugh at them a lot. All the time. It's a thing. But point is that, yeah, no, old batteries work pretty darn well. They're biodegradable now, easily replaced fluids, and very quick to immediately get back up and running. If you get into an accident, it spills, but it's no worse than, well, anything out there. In fact, it'd be better than even gasoline with how little impact it would have, and same thing for freaking refrigerants we've been wanting to get rid of for a while anyways. We don't want to add anything that's bad like that into that. So, phase changing is an interesting way to get around certain boundary layer issues with vibration, and it also helps cool it and gives us greater amounts of control over every molecule here and the reduction of the oxidation. So as it goes and it gets spread, we have a higher surface area, but we also have more field that we can affect and more light that can go through and pass in between, and we can alter those densities as a branch wave design. Now, that means each section is a sweet spot section for the gases in our atmosphere and the fluid we're using with the light we intend to add. Now, it extends the range, sure. It also could just sit still and start recharging like old batteries used to. I think nickel versions are pretty hefty, but they used to just slowly recharge themselves. Really cool, but they couldn't really produce much, right? Now they can. Wonderful stuff. And that's basically the whole design. See you later.